Today I'll cover chapter 15, which is the Equilibria of other reactions. And this has to do with ionic compounds and the dissolution reaction. While some ionic compounds are considered insoluble, all ionic compounds dissolve in water to some degree. This dissolution is very little, but there is some. They dissociate into separate hydrated ions, and solid plus ions in solution at equilibrium. For instance, here we have copper and sulfur, which has a dissolution and becomes copper 2 plus sulfur 2 minus. Okay, and we want to here note that K is for ions are KSP, or the solubility product constant. And I want to note that polyatomic ions do not split in the solution. These are the common polyatomic ions. These should already be memorized. But for reference, they are ammonia, acetate, hydroxide, nitrite, nitrate, permanganate, dichromate, carbonate, bicarbonate, phosphate, chlorate, perchlorate, sulfate, sulfite. Molar solubility is the solubility of a compound expressed in units of moles per liter, or it is the ratio of the molarity. Common ion effect is when a common ion, to begin, is an ion in a solution that is supplied by more than one solute. The solvent is the solution having the ion added already contains that ion. A common ion effect is the solubility of an ionic compound is lower in a solution containing a common ion, that is, in pure water, than it would be in pure water. This is because of Le Chatelier's principle. For instance, if a solution already contains, let's say, iodide, then this would mean that the reaction has too many products and would need to shift left. If it shifts left, then it would produce more of the lead iodide, which would be solid and would precipitate more. So we would see that the solubility would decrease. Here, the effect of pH on solubility. For an ionic compound with basic anion, we'll discuss what a basic anions are in a bit, but the lower the pH of the solution, meaning if it's acidic, the higher the solubility, and the higher the pH of the solution, meaning it's basic, the lower the solubility. We can think of this as a crisscross pattern. For a basic anion, as the acidity decreases, the solubility increases, and as it becomes more basic, or that the pH increases, the solubility decreases. Common basic anions are those containing hydroxide, anions or weak acids, and fluorine, sulfur, phosphate, and nitrite. A good way to remember this is that funny squirrels play nice. This is also due to the Le Chatelier's principle. This is because if you have a solution that is basic, meaning it has OH, and you add to it something containing, let's say, a common basic anion, which could include hydroxide anions, then you would essentially this would essentially become the common ion effect, where there would be OHs already, and then it would dissolute into OHs, so you would have more of the product, and so your reaction would shift left, or that the solubility would decrease. Okay, to determine if a precipitate will form, we would have to compare Q and the KSP, or the solubility constant. If Q is less than KSP, then the solution will be unsaturated because it is less than equilibrium, and when more solid is allowed to dissolve, and no precipitate will form. When Q is equal to KSP, it will become saturated, but additional solid will not dissolve, so the additional solid will precipitate. If Q is greater than KSP, the solution will become supersaturated. The excess solid will precipitate out, and there will be precipitate formed. Selective precipitation refers to a technique in which ions are separated using differences in their solubility with given precipitate reagent. The ion that requires the smallest amount of added ion precipitates first, and that's why we know it's less. That's how we separate them based on their precipitation or solubility. Here we want to cover the Lewis-based theories for acids and bases. So acids, according to this definition, are any species that accept a pair of electrons. This can include incomplete octet, double bonds, or small highly charged cations. It could be good to memorize these compounds, these small highly charged cations here for testing and other matters. So a good way to remember them is to have Cha, krypton, hydrogen, aluminum, iron, and silver. Bases are any species that donate a pair of electrons. Here we have some other things